Have you ever wondered how a little ice can have a big impact on an aircraft's performance? This seemingly innocent phenomenon, known as icing, is actually a critical issue in aviation. It's characterized by the deposition of ice on an aircraft surface, which can occur anywhere from the leading edges to antenna tips and rivets. This video will explore the science behind the formation, types, and effects of icing. Now that we've set the stage, let's delve into the fascinating science behind ice formation on aircraft. Ice formation on aircraft is a complex process that involves various atmospheric conditions. It mainly occurs through three processes. Let's take a closer look at each one. Firstly, we have the freezing of supercooled water. Picture this: supercooled water droplets are floating about in the atmosphere, minding their own business. But when they come into contact with the aircraft surface, they freeze instantly. This is the most common form of icing, and it usually happens in clouds or during precipitation. Next, we have the freezing of liquid water. Imagine water at a positive temperature sitting on the aircraft. As the ambient temperature drops below freezing, this water also freezes. This type of icing is less common and usually associated with ground operations or areas on the aircraft where water can collect and then freeze. Lastly, there's sublimation. This is when water vapor turns directly into ice without becoming liquid first. It's like skipping a step in the process. This mainly occurs on the ground or during descent from high altitudes, where the aircraft surface is colder than the surrounding air. Each process contributes to the formation of ice on an aircraft, but the conditions and the specific parts of the aircraft where this happens can vary greatly. So we've learned how ice forms on aircraft. But what does this ice look like, and how does it affect the aircraft's performance? Ice on an aircraft isn't just ice, it comes in various forms, each with its unique impact. Let's start with rime ice. It's an opaque, rough, milky ice formed by the rapid freezing of small supercooled water droplets. You'll usually find rime ice in colder temperatures ranging from 0 to -10 degrees Celsius. The rough texture of rime ice can disrupt the smooth airflow over the aircraft surfaces, thereby increasing drag. Next up is clear ice. It's transparent, smooth, and forms when larger droplets freeze slowly, allowing them to spread before solidifying. This type of ice is heavy and can significantly alter the aerodynamics of the aircraft. The slick surface can fool you into thinking it's not much of a problem, but don't be deceived. Clear ice can add substantial weight and dramatically change the aircraft's shape, leading to a reduction in lift. Then we have mixed ice, which, as the name suggests, is a combination of rime and clear ice. It presents characteristics of both types, depending on the fluctuating temperatures and water droplet sizes involved. Mixed ice can be particularly treacherous as it combines the weight and shape-altering properties of clear ice with the rough, drag-increasing surface of rime ice. Now let's talk about where this ice tends to accumulate. The leading edges of wings and tail surfaces are prime real estate for ice accumulation. This can alter the airflow over the wings, potentially leading to a loss of control. Ice can also form on propellers and intakes, disrupting the airflow and affecting engine efficiency and thrust. In other words, ice can make your aircraft work harder and perform less efficiently, a combination no pilot ever wants to face. Understanding the different types of icing and their effects is crucial for pilots to maintain control of their aircraft in icy conditions. So whether you're a seasoned pilot or an aviation enthusiast, remember, knowledge of icing isn't just cool to know, it's a matter of safety. Now that we've explored the science behind icing, how does it affect flight operations? Icing demands an extra level of vigilance from pilots, particularly during unfavorable weather conditions. It's not something to be taken lightly. Ice accumulation can drastically change an aircraft's performance, increasing drag and reducing lift. This can alter the stall speed and handling characteristics, potentially leading to a loss of control. Ice forming on leading edges disrupts the airflow over the wings and tail surfaces, while ice on propellers and intakes can affect engine efficiency and thrust. These are all factors that can significantly impact flight operations. It's not just about understanding these effects, but proactively managing these icing conditions that ensure a safe flight. It's vital to remember that icing can occur on any part of the aircraft exposed to the wind or featuring angular elements, like antenna tips and rivets. Remember, knowledge is power, and understanding icing can make all the difference in aviation safety.